rewritten version, expanded to approximately double length with enhanced clarity and style. The Earth, as we know it, is not a static, unchanging sphere. Every moment that passes, our planet undergoes a host of modifications, from the subtle to the monumental, shaped by both natural processes and human influence. As our technology advances, we're constantly amazed by new discoveries, from awe-inspiring findings across the universe to startling revelations about our own home world. Some of these discoveries captivate our curiosity, while others set off alarms for scientists. Have you ever contemplated the idea of our planet exploding or suffering a catastrophic collapse? A few decades back, such a notion would have seemed outrageous. Yet, these days, mounting evidence suggests that Earth is experiencing dramatic environmental and geological changes that could, in theory, trigger large-scale disasters. Despite the environmental pressures created by humans, like global warming, widespread pollution, and the depletion of natural resources, scientists also point to other powerful processes quietly unfolding beneath our feet. A surprising amount of water is being drawn into Earth's interior, and the potential consequences of this phenomenon are both intriguing and alarming. This process has persisted for millions of years, but it's only recently that researchers have grasped just how massive the flow might be. Some have even suggested that the accumulating water within the planet's crust and mantle could alter tectonic dynamics to the point of causing large-scale catastrophes, perhaps accelerating seismic activity, fueling volcanic eruptions, or reshaping entire continents over the next 1,000 years. Over recent decades, global warming has intensified, bringing about severe consequences. Formerly lush regions are drying out and becoming deserts, and areas that once had ample fresh water have found themselves with dwindling supplies. Meanwhile, the Arctic is losing its ice at an unprecedented rate, and more than half of Earth's major groundwater aquifers are shrinking faster than they can replenish. These aquifers, which supply over 1/3 of our planet's fresh water, can take millennia to recharge through the gradual processes of snowmelt and rainfall. Beyond human consumption, Earth itself drinks some of this water, and nobody fully understands where it all ends up. While scientists have long been aware that tectonic processes carry ocean water deeper into the planet, new research indicates that the amount of water pulled under by subduction zones is 3 times larger than initially thought. Subduction zones form at the boundaries of massive tectonic plates, gigantic slabs of the Earth's crust that move, collide, and reshape the planet's surface over millions of years. At these boundaries, one plate dives beneath another, sinking deep into the upper mantle. A striking example is found in the Mariana Trench in the western Pacific Ocean. Not only is this crescent-shaped scar the deepest spot on Earth, descending around 36,000 feet below sea level, but it is also a laboratory for studying how the planet swallows large quantities of water. By deploying an array of ocean-bottom seismographs and combining those data with land-based instrumentation, researchers detected seismic wave patterns suggesting that hydrated rocks extend nearly 20 miles beneath the seafloor. This deep hydration is far more extensive than prior models had anticipated. Many people wonder how rock can store water. The key lies in a mineral called ringwoodite, a high-pressure form of olivine that traps water at great depths. Under the extraordinary temperature and pressure conditions of Earth's mantle, ringwoodite can store a tremendous amount of H2O. If just 1% of the transitional zone in the mantle contains water, that reservoir could be 3 times the total volume of all our oceans combined. The planet's internal water cycle doesn't just influence the geology of subduction zones, It can also play an enormous role in generating earthquakes, since water-laden rocks act like lubricants along fault lines. When a tectonic plate saturated with water descends into the mantle, it can destabilize Earth's crust in ways that trigger more frequent and more intense seismic events. Earthquakes strike our planet thousands of times each year, averaging roughly 20,000 tremors annually, equivalent to about 55 earthquakes every day. Of these, around 15 are strong quakes, measuring around magnitude 7, which are significant enough to cause considerable damage. An additional concern is how the Earth's rotation might connect to seismic unrest. Scientists have observed a link between slower planetary rotation rates and heightened earthquake frequency. In other words, if Earth's spin rate continues shifting, and there's an extra influx of water into the mantle, we could witness a substantial escalation in seismic and volcanic upheaval. The resulting quakes, volcanic eruptions, and possible tsunamis could be devastating on a global scale. Volcanoes and earthquakes often go hand in hand. When large volumes of water are introduced into the deep mantle, they can lower the melting point of rocks and encourage the production of magma. This increased volcanic activity may be playing out right before our eyes. More than a dozen American volcanoes, such as Hawaii's Kilauea, Alaska's Mount Redoubt, Mount Okmok, Akutan Island, Mount Spur, and Wyoming's infamous Yellowstone supervolcano, have been flagged as high or very high threat sites. Yellowstone in particular stirs both scientific and public anxiety because of its history of massive super-eruptions. Beneath its 45-mile-wide caldera lies a tremendous volume of magma. If water from subduction processes contributes to the growth of that magma reservoir, any future Yellowstone eruption would have extreme worldwide repercussions. A vivid reminder of volcanic force came in December 2018, when Indonesia's Anak Krakatoa erupted violently. Part of the island collapsed into the Sunda Strait, generating a tsunami more than 7 feet high that devastated shorelines. Incidents like this underline the planet's geologic volatility, potentially tied to the massive intake of ocean water sinking via subduction. Although scientists believe the Earth has a kind of internal water cycle, with some water eventually returning through volcanic vents and hot springs, the overall math is unsettling. Far more water is being subducted than what is expelled. If this discrepancy continues growing, Earth's surface waters could gradually diminish over geologic time, making our planet look increasingly barren, perhaps, in the extreme distant future, more akin to Mars than the watery world we know today. While such scenarios may strike us as frightening, Earth has weathered extraordinary events in its 4.5 billion-year existence. Geologic records reveal epochs of ice ages, global-scale volcanic winters, and collisions with massive asteroids. The planet has endured radical transformations before, reshaping land masses and obliterating species, only to give rise to entirely new evolutionary chapters. We, as humans, are merely the latest chapter in this story. In our quest to understand subduction, internal water cycles, and how all these factors tie into volcanic and seismic activity, we might at least improve our predictive capabilities. With advanced seismographs, satellite imaging, and better geochemical analyses, scientists hope to develop earlier and more accurate warning systems. Yet even with all our expertise, there's no stopping Earth's geological processes. The best we can do is learn how to adapt, mitigate harm where possible, and remain prepared for the inevitable changes our planet will experience. Ultimately, Earth will keep shifting and evolving, often at a snail's pace, but sometimes with astonishing speed and force. Regardless of how much we pollute, overuse resources, or alter landscapes, the planet's internal engines continue to churn. We are passengers on this vast, dynamic world, with only a partial understanding of its immense power. Even so, ongoing research into subduction zones, water entrapment, and tectonic changes is shedding new light on how our planet behaves. The more we discover, the better we can prepare for potential disasters and gain a deeper appreciation of the forces that shape our existence. Though we can't halt the next large earthquake or volcanic eruption, at least our awareness and scientific advancements might buy us some time to act wisely. Thank you for joining this journey into Earth's geological mysteries. If you have suggestions for topics you'd like us to tackle next, feel free to share. And if you found this expanded overview enlightening, don't forget to subscribe and enable notifications, so you'll be among the first to know when fresh content is released. As always, thanks for watching. Until next time, stay curious and stay prepared for whatever planet Earth has in store.